audience ask some questions as well. Thank you. A little bit of a disclaimer. We're talking about generative AI systems, which Progress Software does not make. What we do is we make the systems better and more reliable and more trustworthy. So imagine you're on the brink of a new GenAI initiative, and you're getting really excited about launching it, and you're thinking about all of the things that could go right, but you also need to seriously think about all the things that can go wrong. And this is really important in GenAI systems because you have probabilistic behavior and not deterministic behavior anymore. And understanding the limits of what your system can do and what it can be used for, what's fit for a use case, what level of reliability you need, those are all sort of the things that you have to worry about in order to prevent the failure. And this was a really interesting stat from Gartner, pulled out really recently, that about 30% of projects between now and the end of 2025 are going to be terminated, right? That's a lot of projects. That's a lot of resources, a lot of money, and a lot of dollars going into this thing. The reasons are here, and normally I would highlight those in red, but the reason why I'm highlighting those in green is because we can help ameliorate these issues, right? So the key issues that I want you to take are poor data quality. Garbage in, garbage out still stands. If your information architecture is not good and your data is not clean, you're gonna get garbage answers out, right? That's just the way life is. Inadequate risk detection, right? So how much reliability do you really need to get the right answers for your customers? Also, can customers hack their way into incorrect answers, right? This is a whole new attack surface that now is beginning to come into play, and Google will be happy to talk about that as well. All right, so costs are really important. Inferencing costs are not cheap, and we'll talk about a little bit about that and how to potentially reduce that. And if you don't hit your reliability and repeatability targets, then the business value becomes very murky and unclear, right? So these are all things that I want you to keep in mind when we get through some of the presentation part. This was also a really interesting article from Forbes. Basically, the article is, this is the year of proprietary data and not AI. And that is, people have been starting to figure out that if your company has proprietary data and you can provide the right proprietary data at the right time to the GenAI based on what the user is interested in, what their intent is, what their role is, what their security profile is, then you've got a winning proposition, right? So that's also something to keep in mind. So what we're going to talk through here is basically we're going to go over 3 different architectures just to give you sort of a comparison of what you can do and how you can achieve high levels of reliability. And then we'll go through a demo that shows the three different architectures working simultaneously together, so you can sort of very rapidly compare. In a real world scenario, you wouldn't do that. You would, of course, pick the best architecture that you possibly can and implement that. Right? So the first thing we're going to do is go through those 3 architectures. And the first thing I tried when, about a year and a half or more than a year and a half ago now, when I got access to these puppies, was just plain old, hey, let's ask it questions and see how well it does, right? And, you ask it questions, you get some answers back. That's like architecture 1 here. And the second question I asked was a math question, and these things in those early days were really bad at math, and it got it wrong. And I'm like, okay, I can add to your, I guess my second grader can add 2. This thing is having a hard time with this, right? So it's a matter of understanding what the capabilities are and how I can use them, right? So that's an important piece of the puzzle. The other thing is that in this scenario, these models are trained on mostly public data and not your private data. And so the real question is, what do I do? How do I bring my private data into the loop, and how do I get that to work properly, right? So the next architecture we tried out And all of us were learning very rapidly early on, beginning of last year, was basically what I'm calling an open book exam with the ability to get to the right page. So here, the idea is to bring chunks of data into a searchable, discoverable, retrievable system. Uh, and why chunks? Well, because generative AI systems have windows in which they do inferencing compute, and you want to shove as much context into that window as possible. And if you have, 1,000-page dictionary of terms or something, not all of that is relevant for the question that the user is asking. So you really got to find the right thing in that tome to feed the Gen AI so that it'll be able to answer the question or do the task properly, right? So once you have that data prepared in that way, like getting it ready for a Gen AI system, the next thing is, okay, when I do the search, instead of feeding that search or question straight to the Gen AI, you just analyze what the user is asking. What is their intent? What are they trying to do? And based on that, try to find, say, the top 50 chunks of data that you want. And this is called a RAG architecture. And literally, when I was trying this out for the first time in like early last year, the next day I watched a YouTube video from Harvard doing the exact same thing, and I'm like, okay, misery loves company. So we were onto something. Let's go forward and try to push the boundaries on this, right? So then the idea here is, okay, you get your 50 chunks, you feed as many of those 50 chunks as you can within the window of compute that the Gen AI has available. And these windows are getting larger and larger over time, which we'll not talk about today, but we can totally discuss later. But uh, when you do this, out of those 50 chunks, you may or may not have relevant information again, right? So you might, in fact, you probably will be feeding a lot more non-relevant information than possibly even relevant information to the Gen AI. And so now it becomes context. How do you deal with that context? And the next step is the Gen AI takes whatever you gave it, the question you gave it, and it responds. And this is a very typical RAG architecture, right? Um, but we wanted to get further. We wanted to get to arbitrarily high levels of reliability, repeatability, accuracy. And the reason is because most use cases are not good with a 70% of the time correct answer, right? Which is relatively easy to hit. 80% is harder. 90 is even harder. 95 is super hard, and 99 and above is very, very difficult. And so that's what we wanted to hit. So we said, all right, let's see, where do we go from here, right? So so what we did is we decided to pair the retrieval mechanism with a knowledge graph capture mechanism. And so what we're doing here now is we're allowing the enterprise to capture subject matter expertise within the enterprise into a knowledge graph. That knowledge graph is then able to be used repeatedly across many users, many questions, many use cases. But the nice thing is we're actually capturing corporate subject matter expertise in a way that we can use it and scale it at the machine level, right? So that's the other piece of the puzzle. So now when we get a question from the user, we're not just trying to figure out the key words, we're actually looking at the key concepts that are in the user's task or question. And those concepts get higher priority when we try to do our search and try to find the content that's relevant. So what this will do is, let's say I got my top 50 documents, and the top one was about Apple, the company, and the next one was about Apple, the farm. And the question was, the question had something about, how do I fix my iPhone, my Apple iPhone's something or other, right? Then obviously, us humans go, oh yeah, the Apple, the company is the one that needs to be prioritized, right? But distinguishing that is not very easy to do. But if you have semantic graphs, you can distinguish those sorts of things very readily. And so that's part of what the job of the semantics is of the question or task on hand. Then the other thing to think about is, okay, let's say we do get the top 50 documents ordered by semantic concepts that we looked at. Even within those top 50 documents, there might be like 5,000 sentences. Which of those 5,000 sentences are really the important sentences that the GenAI needs to answer the question? And which are the ones that are kind of superfluous and not part of what the subject matter expert has said is important? So we can take those 5,000 sentences and say, let's just filter out and not necessarily change the order, but at least just filter out what we present to the GenAI and say only present 800 of those 5,000 sentences, right? So once again, we're trying to reduce the amount of non-superfluous information that the GenAI gets before we give it the task on hand, right? So that's another place where that same knowledge graph can be used. Then when the GenAI answers, we can look at the answer and go, hey, does this answer have a certain level of concepts that we expect it to have in the answer? And if the answer is like, no, none of the concepts that the subject matter experts have approved as being valid concepts are shown up, we might short circuit it, and before we even return it to the user, go back to the GenAI and say, guys, try again, because you're not matching the concepts that we think are relevant to the question or task on hand, right? So yet another way to filter and give you better reliability in terms of the answers. Not only that, but you can also ask the GenAI politely to give you sort of references back to the original content, so users can click on it and actually see where their content is coming from, right? So that also gives you another really good insight into this. So we've already talked a lot about some of these issues, right? Hallucinations, data bias is another one that I haven't just mentioned yet, but when 4.0 just got released, like literally 2 months ago, I gave 4.0 my picture and said, draw me a digital avatar from this picture. And the first 3 times it tried, it drew white guys. I'm sorry, I'm not a white guy, right? I don't look like a white guy. And I was pushing it hard, and it was still drawing white guys, right? And finally, the fourth time around, I'm like, dude, I'm a South Asian. And it started drawing South Asians, but they didn't look like me either, right? So I'm like, all right. And finally, I don't worry, I'm going to give up on this task for you. And like, sorry, you got frustrated, right? So it understood that I was getting frustrated, or it pretended to understand, or simulated that I was getting frustrated. So lack of human understanding and lack of reasoning is also a problem. But if you can give it an example of, hey, digital twins means is a concept, and this concept has 10 different synonyms, or can be mentioned 10 different ways. And here's an example of all those different ways that they could show up. And here's a JSON LD file that represents that. So it can map the JSON LD file to the logic that's in the example that's showing that these things are equivalent. Then it can do reasoning in a much better and much more reliable way. In fact, we found that when we just gave it the JSON LD file, it was not understanding it half the time, right? But when we gave it the LD file with the example of this is the same, then we got it to really do reasoning in that space for that specific level of inferencing, right? So these are the kinds of things that you have to start thinking about in terms of improving reliability, right? Just moving on to the next slide, because we got lots of things to cover. What it boils down to is the context you give these things before you tell it to do its job or answer the question is super, super important, right? Now, this is a context issue, so this is a meta picture here. I'd like somebody to raise their hand who hasn't seen this picture before and tell me what they think is in the background of Context is King. Come on, don't be shy. Puzzles. I get that very often, and it's absolutely right? A portion of this is a puzzle, but this is the full context of it, right? So again, the context and the information around that is very, very important, right? So seeing that full picture, you would give me a different answer. What would your answer now be? A throne. There you go, right? Recently we came across this study. This is not done by us, but this is a really interesting study. And this is 3 different kinds of retrieval, right? So over here, this is the data set here is called the Squad 2 data sets. It's built by Stanford. And there's about 20,000 paragraphs and about 40,000 questions. And the way it's constructed is those questions can only be answered by 1 paragraph. So if the right paragraph didn't come back, then it's very easy to detect. All right. And so this is the recall rate. Did the right paragraph come back? And this is how many paragraphs did I have to pull back to get the right paragraph for the question being asked, right? So if you're thinking about Google's first page, then I would draw a line at 10, right? And so if we look at 10, then if we're just doing a regular search, the right paragraph would come back about 86% of the time. If we were doing a vector search, the right paragraph would come back maybe 87% of the time. So we can see vectors are slightly better than regular search, okay? But if you take the regular search and combine it with vector reordering or vector relevancy, you get 90%. So this is a case of two technologies combined together is better than one technology alone, right? And this led me to the thinking of, well, if search and vectors is better than either of those two alone, then why not use all the retrieval technologies in your tool belt to get the right content back for you? Like you should be able to use search and vectors and key value pairs and co-occurrences and SQL, right? All those things should be mixed together depending on the use case, depending on the questions, and depending on what you're trying to answer, right? And if you want even better recall than what you're going to get out of these generic sort of systems and generic algorithms, you need to start building custom graphs. Okay? And custom graphs used to be hard to do, but thanks to GenAI, they're getting way easier to do, and we'll talk about that. So this was a use case that I like with a large pharmaceutical customer 5 years ago, before GenAI was the thing, and they had drug product labels. They said, no matter how the user asks the question for this drug product label, I want the right answer to come back in the top 3, right? If you look at this graph, you're like, this ain't gonna cut it. Like, because top 3 means I'm like only 75% of the time or 80% of the time, I'm gonna get it, right? And so if I had relied on just these two technologies and not a custom graph, I would have failed, right? But within, I'd say 30 days of elapsed time, a lot less actual time, we were able to hit 100%. Always the right answer from the drug product label showed up in the top 3. And about 80% of the time it was showing up as the first answer, right? So we hit the requirements of the use case, right? So this gives you a feel for, hey, if I want these things to be ultra reliable and if I want the answers to be ultra tight, I need to start doing things like this and giving them the right context so that they can give you the right answers, right? So the thing that we're talking about here from an architectural perspective is the last architecture I talked about was we're calling it validated generative AI semantics. Why are we calling it validated? Because we have a human in the loop, right? We're thinking about having the human knowledge be captured in a very repeatable, reliable way, right? This is a fun analogy. I took a picture from last summer. It was 38 megabytes. I compressed the hell out of it. And this picture is 21 kilobytes. The compression ratio is 1600 to 1, right? And this is what I got out of the center portion of that. So this is really about 4 kilobytes of data or something like that, right? When I put this into PowerPoint, this is a close-up of a hand. Okay, I can kind of see a hand there. Anybody else want to take a guess? All right. Well, somebody take a guess. Navy pier, okay, or an alligator, sure. All of those are perfectly fine at this level, right? I've also had like modern art, right? It works for me, right? So this is 800 to 1 compression, right? You're beginning to see a little more of it. Now, does anybody want to take a guess what this might be? Sometimes people actually get it right, huh? Oh, like your body of water, you're close, okay? The sunset, correct, but even better. And this is like 8 to 1, right? And this happens to be a sunrise instead of a sunset, but whoever said that got pretty close, right? So this is the actual picture. My daughter convinced me to go to one of the islands, shall we say. What do you think this little thing is over here? A ship, right? Sorry, I guess I should have gone over to here. I can't really see that. I'm sorry. I better move. Yeah, okay. Now, and then there on the right-hand side, there's a little curved thing, which might be hard to see in that screen up there. But that ends up being a bridge, right? And it's the bridge to Paradise Island. So having context helps us figure out what the meaning is of things, right? And helps us get better answers of things, right? So now, why did I do this? Well, about 6 months ago, I did some research around the GenAI systems. The first four here are from OpenAI. The last one is Google's. And what I did was I just tried to figure out sort of compression ratios, because you can think of these things as knowledge stored in a compressed model, in a lossy compressed model, right? The more you compress it, the more knowledge you lose, but the faster you can retrieve it, right? So that's a really interesting way of thinking about it. And for the most part, I don't really want you to look at the numbers other than, highly compressed, a lot less compressed, a lot less parameters, a lot more parameters, right? So what this means is the stuff on the left has a lot less understanding of the real world. The stuff on the right has a lot higher understanding of the real world, right? So a lot better understanding of the world's knowledge. Okay. So if we go back and we look at our our ability to capture semantics, a lot of pushback I get from customers before, like 2 years ago, was, hey, how do I generate this for my org, right? How do I get like 10,000, 100,000, or a million semantic concepts related to each other across my org? That's a tall order, right? That's really hard to do. And the answer used to be yes, you have to have basically librarians or experts help you create that, right? Um, and so that was the way to do it. Bring in librarians and experts, and they'll help you create that model. And it will take a lot of human effort. But then along the way, we said, well, all of our end users should be able to suggest changes and create new concepts, or create new synonyms, or create new relationships between these concepts, because they're using the system every day and they're seeing what pitfalls are working and what's working in the model and what's not working in the model, right? So the idea here is to say, okay, we can build a knowledge review tool where your end users can look at that content too and suggest changes, which is great, but it's still a reasonably heavy lift, right? So the next thing we did is we said, all right, what if we just paired the smartest of the Gen AI models with the subject matter experts and see how rapidly they can do it? And when we did this, and the latest release of Semaphore has this capability built into it, basically we had one guy generate 800 concepts in half a day, right? So that's sort of the level of improvement that went forward, whereas normally that would have been like 30, 40, 50 concepts in a half a day, right? So orders of magnitude better in terms of the productivity of the people who are trying to capture the enterprise knowledge, right? When you go to OpenAI's website, or most of these guys' websites, they're like, hey, you can do automated semantics using our text embedding models. But what you get is what you get, literally, right? If your corporate knowledge is not embedded in that text embedding model, then guess what? It's not going to be able to find the data that your corporate experts can find and say this is important, this is not important, right? So one piece of the puzzle. The other piece of the puzzle is text embeddings have to be done on all your data. So if you have 100 billion chunks of data, you have to run the text embedding model 100 billion times, right? And text embedding models change every 3 months, so you got to do it repeatedly, every 3 months at a minimum. Or every time you add more data, you got to do it, right? So this is an expensive proposition. On the other hand, changing your graph, adding a relationship, adding a reliable, this thing is the same as this thing, or this thing is a subconcept of this thing, is instantaneous, right? The number of concepts on the semantic side is 100,000, or at most 1,000,000, right? So adjusting that million set of concepts is really easy to do, right? So that gives you a lot of agility in capturing your knowledge, changing your knowledge, updating your knowledge, and it doesn't cost you a lot of compute either, right? This is so we're not saying don't do this part. We're saying it's very useful. It's a tool in your toolbox. Totally do it. But this other tool in your toolbox can really help supercharge the reliability of your answers. Right? Okay, and the other piece of the puzzle that we figured out is that not only can we use the Gen AI to help us suggest the model concepts, but we can watch what users are asking, and from that automatically extract concepts and discover if those are already exist in our corporate graph or don't exist in our corporate graph. And then because we have human in the loop validation capabilities, we can very rapidly approve the new concepts or the new relationships into the corporate knowledge graph. All right. The other thing that's really interesting is because we have a lot of different ways of finding the data besides vectors, if your users are only interested in 1/4 of your data, why are you vectorizing all of your data? You should only vectorize the quarter that they're interested in, right? And that could be an order of magnitude reduction in your vectorization costs, right? So another thing to think about. All right, so we already talked about this. Key takeaways is we have a way of really rapidly building your graph, and we also have a way of reducing your costs, right? Human in the loop. So the next thing we're going to do is just give you a really quick demo of okay, yeah, really quick demo of what we've put together in this space, and basically, yeah, questions. So I can do that. Does anybody have any questions? All right. Clear as mud, right? Yeah, go, Gina. Yeah, it's a single API. Yeah, so in fact, because of our multi-model nature, we've actually built a single API against all of the models. So even SQL-like queries, graph-like queries, key value pair queries, co-occurrence queries, regular search, all through a single API, right? And the nice thing about that is you define what you're looking for, and then the system goes back and compiles it and says, oh, the search is going to narrow things down really fast. Let me do that part first, right? So we can give you sub-second response times because we can pick and choose which of the parts we want to filter out first. Very good question. Okay, so the scenario that we used is, hey, we're a tech company, which we are. We have a lot of product documentation, like 20,000 pages on just one of our products. It's really hard to find stuff in that. What if we automated that and allowed people to ask questions of that content in a very rapid way, right? Business value is reasonably high because instead of my customers asking me those questions, they can just go to the Gen AI and ask the questions. And if they get reliable, trustworthy answers, then I get freed up to do a lot of other things. So for me, the business value is super high, right? So for this demo, we put that in place. We are actually figuring out ways to move this into production, and we're figuring out ways to move it for our customers into production as well, right? So at this point, I will flip over to the demo. Let me just refresh my page, make sure I'm still logged in. Okay, it looks like I'm still logged in. All right. So the first thing I'm going to do is I'm going to ask a pretty generic question, right? How? Am I not seeing that? Oh shoot. Let me see. Command tab. Command tab. Let's try that. Nope. No. Let me stop presenting, and I think then it'll work. Get out of present mode. Escape. Yes. Okay. Here we go. Now we're good. Yep. All right. All right. So I'm not going to switch back and forth because that's not going to work right now. But let's say we ask the question, how can mark logic be used for ISO 20022? Now, The reason why this is really generic is Mark logic is a well-known concept, and ISO 20022 is also a very well-known concept. So I expect when I hit submit, all three of these to give me some answer. So the first, the thing on the left is the just ask the GenAI directly, right? This one is ask the GenAI, but also have the GenAI help identify concepts automatically in the system, right? And then this is human in the loop validator stuff. So here, I'll give this one a thumbs up. I'll give this one a thumbs up. And this one, it answered it. But if I click on this link here, and let's just go ahead and do that, I can bet you it's not going to take me to the right page. Okay. So let's go back over here. So I'm going to give this a thumbs down because this thing is a hallucination. Right? It's totally made up. Right. On the other hand, if I click on this one, I get the chunk of data that actually was used to create the answer, right? And then if I click on this, it'll take me to the actual document that the answer came from, right? So really easy to validate and see where my content, where the answer is coming from and why it's coming properly, right? Okay, so another really fun thing that happened when I gave this to my general manager of our division is I told him, hey, the script, this is a demo, don't go off script. And what does he do? He goes off script, right? So I'm going to do exactly what he did. How are, okay, sorry, let's do this. Where do babies come from? Right, this is literally the question you asked, right? I'm like, okay, whatever, go for it, dude. So now you'll see a little bit of risk mitigation here, okay? Right, so you see a little version of risk mitigation. This one, it answers, right? Over here, it says, I'm not answering that question because I don't have the documents that back that up, right? So this is what I mean about mitigating your risk, right? So let's go and ask a more valid question, right? Can you give me an example of when Mark Logic was used for, actually, let's use the digital twins one, and hit submit. So now here, this one sometimes answers or doesn't answer depending on the probabilities and the statistics that come into play. And in this case, it's answering, but again, most likely these are hallucinated. These two come back really nicely as well, right? So this is fine because this is digital twins is a well-known concept. I expect the GenAI to remember that in its knowledge for most regularly compressed models, right? But if I go to device shadows, which is sort of a lesser known synonym of digital twins, and do the same kind of question here, I will most likely not get answers from either of these two systems because they won't know. So this one says, I don't know. This one says, I don't know from the documents. And this one says, oh yeah, I know what device shadows are. They're like digital twins. And here's the documents, right? So this is an example of getting reliability and repeatability based on concepts that your organization knows, right? And a really, really important use case of this kind of concept is sort of internal IDs for a corporation. Like this chemical is known as this ID inside the corporation. It's known as this brand name outside the corporation. It's known as this generic name outside this corporation, right? That's a really good example of a concept tree that is really important to the organization, right? And part of that is public and part of that is completely private within the organization. So the ability to capture that in a reliable, repeatable way is what we help GenAI, and then feed that to the GenAI based on what the user's wanting to do is what we bring to the table here, right? Any questions so far? Is this making sense to people? All right, good. Good. No. We're gonna give it a years name. So you're asking an under the hood question, right? Under the hood, we're doing vectors and graphs, but the content didn't have anything about babies in it. Yeah, if we don't give you content that is relevant, just say I cannot answer it from the content that was given to me, right? Now, of course, you can prompt engineer your way into hacking it, right? But by default, we're trying to be safe about it. Yeah, our content didn't have anything about babies, and so it returned nothing, right? Um, okay. Another a really interesting example is if I ask about, tell me how progressive vectors can save costs. Now, this doesn't have the word mark logic in it, right? So progressive vectors and cost are the concepts that are going to be extracted. This thing's going to talk about progressive vectors and cost, but it's not going to be in the context of the documents that we want it to describe, right? So it does give you an answer, but it's not in the context of what the enterprise wants it to answer for, right? On the other hand, these two give you the answer. They also give you the, hey, go over here and bring up this PDF file that has all of the information in it, right? So very easy to do there, very understandable. The one last thing to show you is that this particular document used to be under NDA before the patents were filed, right? So if I log out here and log in just as the public user and sign in and then ask the exact same question. So tell me how progressive vectors can save costs. No, none of these should be able to answer properly, right? I mean, this will answer something, but probably not around mark logic, right? And these two guys say, I can't answer that, even though they're accessing the same database. The role of the user did not allow this document to be presented to the GenAI, and so the GenAI can't answer because it didn't get the document that it needed, right? So security is tied to the content, which is sort of at the core of where you should tie your security for GenAI systems, right? That's most of what I wanted to present today, and just one more thing here. So the net here is, and I don't know if this is going to go into pre-zoom mode properly or not. Yes, okay. Net here is if you're launching a GenAI project, we can really help you hit reliability levels, improve your reduce your risk. Yeah, all right. A fun question I asked earlier was, hey, does Air Canada give free tickets? And if you guys don't know, Air Canada was liable for giving away a free ticket because their chatbot said that Air Canada should be able to give you a free ticket, right? So that was a fun one. But reliability is really important, and the reliability tied to your content and your subject matter expertise is really important. And what that boils down to is when you increase the reliability, you're reducing the risk of what you're publishing, right? You're reducing liability risk. You're reducing the risk of your customers getting really mad at you. You're improving the trustworthiness people have in the answers. If you give them transparency and you give them the ability to check the answers and they check it a few times and stuff is actually matching up, they're going to go, oh, this stuff works, right? So basically the idea is if you use systems in which you use every tool in your belt to get that context right, then you're going to get very reliable answers out of these GenAI systems. And launch with confidence is what I have to say. You're going to be in good company. We have some really large customers doing this already. One customer saw their reliability jump from 50% to 90%, and that was good enough for their use case. Another customer went into production in weeks. They already had their content in the Progress Data platform, and we just literally gave them reference code, and a month later they came back to us and said, yeah, we're already in production. I'm like, oh, please show us what you did, right? And then one of the big four accounting firms, and I can't name names, tested us against other products, and we are their secret sauce. They are currently saving about $2 million a week in efficiencies, right? So this is the kind of results we're able to achieve. And just I'll open it up to questions. Thanks a lot for some good ones, Gino. And also I want to remind everybody that MarkLogic World is coming up in September, and if you're even thinking about going, just register. It is totally free to register. It's in the DC area in September. Thanks. So any questions? Go ahead. So no prompting at all. This is so access in Progress Data Platform is tied to Active Directory. So when the person logs in, his Active Directory roles get approved, his Active Directory criteria hits, and that's what allows you to see the data or not see the data, right? They are in a database, not in a vector database. They're in the Progress Data Platform, which has row-based security, element level security, and content level security, all built into the platform. So far, under the hood, we're using right now for this demo LangChain. So anything LangChain works with, we've done. Anything Spring version of Spring versions equivalent of LangChain that connects to, we can connect to. And Llama Index is always a good one to try out too, right? We're pretty agnostic. We can run against any of the GenAI systems out there. Good question. All right. All right, so I think maybe let's take a 5-minute break, and we will get our panelists up here, and then restart in about 5 minutes. Thanks. To accomplish the rate myself, the content. So in Semaphore, the concept that we installed, and if I click into my pin, I would see that it's still playing here. And so when we found the token, we're like, oh, we know what that means. I need to for all of this. So then you see to present the nice to be We expected it to iterate on this all the time. You went to graduate, you went to you already were so he gets started. Right, and it's awesome. So for us, the red line is what our speed. Yeah, and I was with my this red line is the red line. And we were close enough with that makes that feel funny. And now it's basically like but our friends another year. Somebody like this. Okay. Mine is right. And it's my 500. Just I got to see by our I want to filter this. I've been there. I've done I don't want to verified as being I just really all all right. So I'm going to try to get our panel of videos. Just on the thing that was live. No, yeah, I wasn't. It's quite a long time. Oh, yeah. Actually, because I haven't they told us that they were going to we had been facing advice for us being what are you really trying to do? And there we just maybe help us and they said that they were going to be Jerry's and it was like, yeah, okay, so I guess yeah, it's like a video diagram of salespeople and on my team, security practitioners and to go through